When reality seems too difficult for us to face, we retreat behind defensive mechanisms. There was the girl who always explained that she really didn't want something after she found out she couldn't get it. She was two-faced. Her defense mechanism was rationalization. He saw illness as a way out. A back way, true, but a way. When it was time to bring in the wood, his legs pained him. When the snow fell, something went wrong with his arm. And he loved the attention he got. His escape mechanism was malingering. The Army calls it gold bricking. He identified himself with a welterweight champion. Every fight the champ won, he won. Every punch the champ took, he took. And he could take it. His escape mechanism was identification with somebody else. She thought that if you pretended a thing wasn't there, it might go away. If you pretended something hadn't happened, maybe it hadn't. If you hid the truth away, maybe it would turn out to be a lie. Her escape mechanism was suppression.
This chunk of ice may look pretty unremarkable at first glance, but put a match to it and something amazing happens. As reported in this month's issue of The Atlantic, it's called methane hydrate, and it's actually not unusual at all. In fact, there are more than 100,000 trillion cubic feet of it on Earth. Volume-wise, that's like the size of the Mediterranean Sea. And it has a greater energy capacity than all the coal, oil, and natural gas on Earth combined. And while methane burns clean, unburned methane is a potent greenhouse gas, and if it leaks, it can be devastating to the environment.
You may remember that in 2007 there was a big study that came out from this group called the Intergovernmental Panel on Climate Change. And they looked at computer models of how rapidly Arctic ice would go away. And as of early 2007, this is what they were telling us, that we would see gradual drop in Arctic ice minimum going down to where we probably still have a fair amount of ice left in the year 2100. Worst case, maybe by 2070 we would see open water in the Arctic in the summertime. That very same year, we saw in the actual observations a huge drop in the Arctic ice, and that drop has continued so that in 2012 this is now where we are.
The faster it gets hotter, the more water vapor. The more water vapor, the faster it gets hotter. The faster it gets hotter, the less ice. The less ice, the less reflection, so the faster it gets hotter. You begin to get the idea? It has to be a downward curving, what we call exponential decay. And if you project that line forward, as is done in this particular setting of the equations and understanding of Arctic ice mass loss, then once again it shows zero ice floating on the Arctic Ocean by the end of summer 2015.
The average temperature of the world is only up a degree, but up in the Arctic it's up 5 degrees. The mirror that's at the top of the world is going to be gone. It won't be gone in the wintertime, but the sun's not shining on it in the wintertime, so it matters in the summertime.
One of the key effects that this has is that when all of these northern areas are covered with white reflective snow and ice, it bounces most of the solar energy off, bounces it back off into space. But when we are seeing more and more open water, dark soil and dark surfaces, then the solar energy tends to get absorbed. So instead of reflecting 90% of all the energy, you're absorbing 90% of all the energy. So this is what scientists call a positive feedback. And they don't mean that it's good. It's not a positive thing for us because it's more like a vicious cycle. More heat equals less ice, and less ice equals more heat, and it just sort of continues on a spiral, and that's what we're seeing in the Arctic.
Permafrost, right here. frozen dirt. Permafrost thaws. The organic matter in the permafrost thaws as well and begins to decay. The microorganisms start to eat it. If there's no oxygen, the microorganisms make methane.
So this is methane, carbon with 4 hydrogens around it, CH4. Methane is the simplest compound of carbon and hydrogen, and it is an enormously widespread molecule in the world. It is the basis of so-called natural gas, the gas that's found deep in the earth and which you can drill down and recover. It's used for heating and energy all over the world. It's also formed when plant material decomposes. So if you have a pond, a little lake, and plant material falls in and decomposes on the bottom, if you stick a stick in, bubbles of gas come up. If you collect this gas, you can actually light it with a match and it burns. And I've done that when I was younger. Methane, when it goes into the atmosphere, behaves like carbon dioxide because it can absorb radiation, infrared radiation, and cause global warming. And it absorbs the radiation via the vibrations of the carbon-hydrogen bonds, and the vibrations when they stretch and also when they vibrate, so-called scissors vibrations. Methane, in fact, absorbs radiation much more strongly than carbon dioxide in the atmosphere, but its lifetime, the molecule's life in the atmosphere, is shorter because it eventually reacts with oxygen and turns to carbon dioxide.
There are potential irreversible effects of melting the sea ice. If it begins to allow the Arctic Ocean to warm up and warm the ocean floor, then we'll begin to release methane hydrate.
According to Dr. Hansen, our planet is on a dangerous course to pass an irreversible tipping point with disastrous consequences. These, already like the melting of permafrost, which in turn releases toxic methane gas, resulting in more warming of the atmosphere. The reason scientists are now turning their attention to methane is that research has shown this gas has a heating capacity 100 times greater than CO2 within the first 5 years. It's very logical, scientifically speaking and otherwise.
Methane is way worse than carbon dioxide. It's inert right now in the soil. It's not affecting anybody in any way. When you warm it, it becomes a gas. Then it starts acting immediately as a greenhouse gas. So this is an immediate and very short-term threat to planetary civilization.
That's probably the biggest issue that we face. Sea level change is a big one, too, a very expensive one to manage. But the methane release from the tundra, once that gets underway, we reach a point where we lose the option of having an effective mitigation strategy.
About 8 years ago, switched to studying the East Siberian Arctic shelf. And actually we've been studying it for the last 8 years, continuously, year by year by year, conducting 1 or 2 expeditions a year. That hydrocarbons are produced within the sedimentary drape was sealed and prevented the methane escape to the atmosphere. That is why we are telling that this should be the largest hydrocarbon stock in the world over there. So the methane in the atmosphere, the total amount of methane in the atmosphere, in the current atmosphere, it's about 5 gigatons. The amount of carbon preserved in form of methane in the Siberian Arctic shelf is approximately from hundreds to thousands of gigatons. And of course, it's only 1% of that amount is required to double the atmospheric burden of methane. But to destabilize 1% of this carbon pool, I think it's not much effort needed, considering that the state of permafrost and the amount of methane currently involved. Because what divides this methane from the atmosphere is a very shallow water column and a weakening permafrost, which is losing its ability to seal, to serve as a seal. Not any time. I think any time sounds like it might happen today, it might happen tomorrow, the day after tomorrow. You think so?
I'm interested in this.
Igor is a very convinced person because he spent a lot of time over there. And where the sea ice should be about 2 meters thick, it was 40 centimeters thick. That means that the processes, all the processes that serve destabilization of everything, of the sea ice, of the water column, of the currents increasing, the currents, I mean the movement of water beneath the sea ice increased. So everything looks anomalous. Even from our experience, from these 10 years, everything looks anomalous. And this is what makes him thinking that, making him think that the worst thing might happen.
No, we cannot exclude this. Maybe it's 1%, maybe it's less, but we cannot exclude because...
Shortly speaking, we do not like what we see there. Absolutely do not like.
Permian mass extinction is, in essence, just the greatest crisis that life on Earth has ever suffered.
By the end of the Permian mass extinction, 95% of all life on the planet was dead. And why is this important today? Because today, a sixth extinction is underway, one that will test the survival of not just human civilization, but possibly of the human species itself. And it bears a horrifying resemblance to several previous global warming-driven events, like the Permian mass extinction. During the Permian mass extinction, greenhouse gases were released by volcanic eruptions in an area that is today called the Siberian Traps. These, along with the heat from the lava flow itself, warmed the atmosphere of the Earth by at least 6 degrees Celsius. That much global warming took a huge toll on land, animals, and plants, but far worse, it warmed the oceans enough that methane, frozen deep under the sea, melted and was released into the atmosphere. That enormous release of methane, a powerful greenhouse gas, pretty much doubled the level of global warming and killed off over 95% of all life, both on Earth and in the sea.
Look at this. In a matter of days, just days, we're having this huge area. Look at this. Going, almost exploding with methane. The only way this is possible is by melting of methane clathrates. It's just the only explanation.
Too many of us refuse to face reality. Too many of us try to escape our duties and identities, our faces and our families. But all these things remain. All the realities remain whenever we leave our dreams and return to the real world.